Hi, welcome to the 22 IDEX setup video. The 22 IDEX is an industrial machine built for high temp. Because of that, it's going to function a little bit different than most consumers are used to. You can print PLA at 450 if you want to. You can rewrite the firmware on the fly. No one's going to stop you. The machine won't give you a warning, but that also means absolute control. Today I'm going to be showing you how to do calibration, setup, and your first print. Now what I'm going to do is turn the machine around so I can show you how to properly plug it into the wall, how to connect the power switch, as well as how to hook up the air purification or BOFA system on the back of the machine. Power is a two-stage process. One, the wall power, which can only go in one way, right here, and the switch. This is the connector for the switch. This actually can only go in one way as well. There is a little key at the top. You find the hole and turn it a little bit. There it goes. It will slide in easily and then simply tighten. We are ready to go. There are magnets on the back, so you can actually place this anywhere you want on the machine, whatever works best for where you've placed the machine. But where we tend to place it is on the side of the machine, right there, in case we need to go over and stop the machine quickly. And it also looks neat when you just tuck it behind this little magnetic door here. So easily accessible, easy to turn off. For instance, if I needed to turn off the machine right now, there you go. Many of our customers have also purchased the air purification system. We call it the BOFA. And there are little slots built into the back of the machine ready to accept it. These are the covers that came on there. You just turn them, pull them off, and actually the hoses go on the exact same way. Thank you, Kyle. Where there are three little marks there. Align them, turn, that's it. Align them, turn, that's it. You can choose which one is the inlet and which one is the outlet. It doesn't matter. The BOFA has only 2 ports. Plug those in and you have air purification. The next step is going to be actually connecting to your machine. But in order to do that, we have to make sure the machine is getting power. Now, your power switch on the side here, depressed means power off, so that you can press it if you need to turn it off during its operation. To turn it back on, we'll simply rotate it to the right until we hear it pop out. There we go. Machine will be getting power, as you can tell from the LED lights. Let's then head over to the computer and look at our Wi-Fi networks. Now, that's our local network here. There it is right there, 22 IDEX. Simply click that, connect, and enter the network security key. When you first get this machine, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Next, we are now connecting to the machine in AP, which means access point mode. What that means is the machine's creating its own Wi-Fi. You're not going to have internet right now, but we'll fix that. Right now, it's creating its own Wi-Fi network so that we can get in and access it. There you go. Now you can see we're connected. It says no internet, but that's okay. The machine doesn't have internet yet. The next step, once you're connected to the machine, will be to go to your browser of choice. It's once again not going to show any internet connection. That's fine. And type in the URL window 192.168.0.1. Now that we've connected, the most important step, Z-Probe pickup. Follow carefully. Z-Probe pickup is crucial because it basically dictates how the rest of the configuration is going to go. One final thing of note is that the resting position for the probe is micro switch up. If you ever have to remove it for some reason, and when you place it back, make sure that micro switch is facing up. That's because when the probe is turned on and ready to be picked up, it rotates so that the switch is facing the bottom. If you were to install it upside down, meaning in its resting position like this, when the printer goes to home, it's going to turn that so the micro switch is facing up and the head would collide with the micro switch. We don't want that. So if it's not being used, it is micro switch up. We're going to begin on the dashboard. That's where your machine should have gone by default anyway. Over to the right here, on the bottom right, you're going to see macros. You'll be here a lot. The calibration is under System, Calibration, and Z-Probe is where we're going to start. The first thing we're going to do is rotate holder to a set degree. As we can see, it's counterclockwise. So going over to macros, we see adjust pickup angle clockwise. We just click this repeatedly until it looks level. So let me get a little closer in there. Maybe a little bit more. Maybe just a little bit more. Yeah, that looks good. That looks nice and flat. We will then rotate holder to 0 degree, which basically saves that offset setting you just did. That has been saved. Then we move on to adjust XY pickup. So let's hit adjust XY pickup position and see what happens. Right now it's basically homing the X and Y, not the Z yet. As you can see, the hot end side is too far to the left. Now, if it's too far to the left, you're going to want to use plus values, too far to the right, minus values. For instance, now we have this handy pop-up on screen. We're going to do X plus 1, and it moves to the right. Perfect. And we just do this until it seems to align properly. And you'll know it's aligned because the hot end side and the probe itself are the same width. They should just look aligned. Maybe a little bit more. I'll baby step that just a bit. I would say that looks pretty good. You finalize and save your settings by pressing OK. And watch the probe get placed back on the servo. If this is all done smoothly, like that, you're ready to go. Now, both ends of the probe connect with a magnet. So you'll know it's properly aligned if you hear that connection go smoothly. There's no clunks, there's no thuds. If you're ever in a situation where the bed is severely askew for one reason or another, let's give this as an example. Don't try to level it like this. You can level it with a certain degree, but for the safety of your machine and all of the leveling sensors, just try to get it somewhat level. We actually have a macro to account for this under System, Settings, Job End Machine Behavior, Bed Position. And you'll see here, lower the bed after the print is finished. When your print is fully finished, the bed will go all the way down to the bottom, and then you can shut off the machine if you want, or have it automatically shut off first. So now what we'll do is we'll home. You can see it's still not perfectly level, but this is perfectly acceptable amount of deviation in the bed. Home all. As you can see, there's still some skew to the bed, but this isn't an issue. Watch this, it's cool. Yeah. So that's true bed leveling, when it'll probe different points of the bed and then actually autocorrect. If that deviation is too huge, it's not going to be able to autocorrect. Now I'm going to guide you through the Wi-Fi setup process. The machine was in AP access point mode. Now we're actually connecting it to your home or work network, so it's directly connected. So your computer still has internet, and this is on your local network. And to do that is actually very simple. In the Dashboard tab, go to Systems, Settings, Wi-Fi, and connect to my Wi-Fi network. It's going to ask you to enter the SSID of the network you're trying to connect to. Please remember that this is case sensitive, and it will only connect to a 2.4 gigahertz network. Here we're entering our SSID and the case sensitive network password. So go ahead and test your network connection when the pop-up appears. Hit OK. From here, it's going to disconnect from the dashboard. You should see the LEDs on the machine turn green. This means that there was a successful connection. Now, please go back to your available networks and wait to see 22 IDEX again. This might take a minute. We're going to go ahead and click Connect. Going back to the Duet web interface, you will see the IP address that you will use to connect when the machine is connected to your local network. We're going to go ahead and press OK, and from here, we've connected to our original network. Go back to your browser and input the updated IP address. Once the machine connects with this IP, you'll know you have successfully connected the machine to your network. From here on out, this will be the IP you use to access and control your machine. Now we're going to show you how to do the auto tool height calibration, which is basically the Z height calibration. Under Dashboard, you will go into Macros, System, Calibration, Auto Tool Height Calibration. It will ask you to set the temperature for the left and right nozzle. It will then prompt you and ask you if you want to start the Z offset calibration. The machine will home again. All right, our nozzles are up to temperature, and on screen we have the baby stepping menu. What we're gonna do is use the standard A4 paper method. A4 paper tends to be pretty much exactly 0.1 millimeters thick. So I'm gonna slide that under the hot end. And what we want to do is baby step that nozzle into the negative to get it closer, and wait until we feel just a little bit of resistance on that piece of paper. Okay, we're getting close. I'm gonna go down to Z.5. How close are we? A few more? Okay, we're now actually too much pressure. So I'm going to do Z plus 0.02. A little bit more. It's getting easier. Okay, that's about perfect. And our new offset is -0.36. So I'm going to go ahead and click OK to save that. Should tool height calibration be performed? We're going to run the calibration for tool height as well. Everything will be on screen. So I'm going to click yes, run the calibration. So what we were basically doing in that first step is just letting the machine know exactly what the gap should be between the bed and the nozzle on the hot end that has the probe with it. The machine is fully aware of where the left nozzle, the one with the probe, is located, the distances between everything. What we're doing now is making sure that the Z gap is the same for the other nozzle as well. Imagine you're doing a multi-material print. 2 colors, let's say. You want to make sure that when that second nozzle comes in, it's not going to run into or collide with the part. They need to be exactly the same height. So that's what we're going to do right now. Now it allows us to loosen the heat break on both sides. Let me show you what that looks like. On the left nozzle, it will be this black bolt on the left side. And on the right nozzle, it will be this black bolt further back on the right side. Now that both of the heat breaks are loosened, we'll just verify. Remember, these nozzles are hot. Use a flathead screwdriver or something similar just to make sure that they move freely. They won't move perfectly freely because, you know, there are heater cartridges and thermistors in there, but as long as they move, you know you're clear. We will then click OK, and what is going to happen is the build plate's going to come up to meet both of those nozzles. So I'm confident we can continue on. So the bed has come up and met both of the nozzles who have the loosened heat break so that they can be the exact same height. What we're going to do now is just very carefully, I will press down on the nozzle ever so slightly and slowly begin to tighten the heat break bolt. Okay, left side is done. I'll do the same on the right. Pressing down ever so slightly and gently tightening the heat break bolt. Simple as that. Now we'll just click OK to save that offset. Now we're getting a second opportunity to fully torque down the heat break bolts now that the bed's out of the way. So don't overdo it. Just a couple pounds of pressure. Click OK when ready. Well, they're fully torqued down, so let's go. What the machine's going to do next is let us double check the deviation between the 2 nozzles. You'll see on screen pops up a Finding Z Offset baby stepping menu. We're going to use the paper method again. It starts at 1 millimeter. I'm just going to go down by -0.5 once because it's already very close, and baby step until I feel some tension. So for this first nozzle, we end up with finding a Z offset of 0.00, which means we had it done properly the first time. All right, on to the next nozzle. I will move down by -0.5 and then baby step by -0.02 until we feel a bit of tension. Perfect. I'm getting some tension. Z offset for the other nozzle is 0.00, no deviation. It worked perfectly. Calibration success, deviation is 0.000 millimeters, but with an accurate machine like this, I'm not surprised. That's the process. The two nozzles are of equal height. We've double checked it, and we're ready to proceed to the next step. Now it's time for Auto XY tool alignment. This is my favorite part. It works really well and it looks really cool. Under macros, dashboard macros of course, Auto XY tool alignment with a probe. So like you saw in the tool height calibration, it's going to ask you for the temperatures on the left and the right nozzle. The machine's gonna home, never hurts to home, and wait for the temperatures to rise on the nozzles. The temperature needs to rise on the nozzles because, believe it or not, even at just 270 degrees, there's going to be some expansion in the nozzles. So it's always better to do any kind of leveling. The machine does it for you, but any kind of leveling at a reasonable temperature. Never do it with your machine cold. Oh, like butter. The machine is now asking us to make sure both of the nozzles are clean them with a metal brush. These have really never been used. There's no residue on there. The reason it's asking you to do this is because if there is residue that is non-conductive, i.e. most materials really, it will not pick up when it touches the sensor. I can verify that both of these nozzles are clean, so let's go to the next step. It's now asking us to connect the probe and place it in the center of the bed. Now let's connect the probe. Upper right back panel can only go in one way. Secure the ring and place the probe in the middle of the bed. Click OK when ready to proceed. I think we're ready to proceed. OK. Watch the magic happen. It's now asking us to slide the probe directly under the nozzle. It doesn't have to be exact, but it does need to be directly under the nozzle. And we can click OK to proceed and watch the magic happen. Let's go. If everything is done correctly, that probe should not move on the bed. Awesome. As you can see, we've done it successfully, and we have a pop-up that shows that. Let's remove the probe. Let's go over some of the features of Duet. First, we'll be starting in the dashboard. The dashboard is where you're going to find temperature settings, movement settings, and your macros, as well as fan control. All pretty self-explanatory. Up here in the tools feature is where you can set the temperature of hot ends and the bed, as well as the standby temperature, as well as choosing the active tool head. For instance, right now we're on right head, but if we want to make the left head active, we'll click that and the machine will clean off the nozzle. And we can set our temperature. Let's just say 200. Because that is the active tool head, it will go to 200. If we want the other head, the non-active tool head, to heat up as well, we would set 200 in the standby section. So that will also heat up as well. Here is the machine movement tab where the holy grail home all button is located. Use that as much as possible, as well as commands for moving each of the axes. Compensation and calibration is also located in the machine movement menu. This is where you basically manually take care of your bed leveling system if you want to. There's the true bed leveling. That's basically when your bed is off to an angle and it will move it to the zero flat plane. And mesh compensation is actually going to probe the entire bed, seeing for any deviations in the surface of the bed, any faults in the surface. Probably the most important menu that you're going to be using is the macros menu. Allow movement without homing is useful, but be very careful using it. It's going to basically ignore its location. So if you select allow movement without homing and ask the bed to go up 400 millimeters, it's going to hit the nozzle. Use that sparingly. Under settings, we have Wi-Fi, which we've covered in the past, and job machine behavior. This is very useful. It will basically dictate what you want the machine to do when your print has finished. You can set chamber temperature to make sure that the chamber temperature stays consistent for hours after printing, as well as the bed and where the bed actually goes. So if you wanted to, you could do a carbon fiber nylon print and hypothetically have the bed go to 200 degrees Celsius and all the way to the bottom. You don't need to, but you can. One nice feature about this is that keeping the chamber temperature the same as the printing temperature, like for nylon, say you want a 65 C chamber. When the machine is done with the print, that chamber will stay warm, keeping the material warm so you don't have to dry it again. You can just get right back to printing. That's a really nice feature. You could even set the chamber to go higher to actually dry it out. We're going to move down right below dashboard to console. Console is basically a log of everything that the machine has done recently. So say you walk away from the machine and the print fails for some reason. You can check in here to see exactly what the machine has done. For instance, we can see at 1:39 and 14 seconds, we made a lead screw adjustment of 2 point, so on and so forth. Very useful feature to have. Under that, under job is status. This is basically while a print's going, you can change your offset on the fly, as well as change how fast the machine is going, how strong the fans are, and even, your flow rate of each of the nozzles. Jobs is where you will have a log of every single print that you've uploaded and wanted to print. So you don't have to search your computer, it's gonna be on the machine. Under macros, that's basically just where your custom macros are stored. Under system, you'll actually have access to the system directory. And what this is basically a program files or a Windows folder for the entire firmware. Be very careful, tread lightly here. If you aren't sure and you don't know what you're doing, I wouldn't touch it. But if you do have to change something, make a backup of that folder. There shouldn't really be much of a need unless you're doing some custom modification to the printer to have to go in here and modify everything. So tread lightly here. If you do know what you're doing, go for it. Let us know what changes you made. Maybe we'll incorporate them. The machine specific tab basically tells you what version of the firmware you're running and allows you to make minor changes to the interface. For instance, what temperatures are going to be available from drop-down menus and so on. Under plugins, Duet themselves do have a few plugins that are available. If we thought they were important, we included them. You also have the ability to use external third-party plugins. They're available online, but we don't necessarily directly support them. So now I'm going to show you how to import the configuration bundle into Prusa Slicer. There'll be a video out shortly on how to do this with Simplify as well. To import the configuration bundle, which will include all of the profiles for the different materials that we offer, you will download the configuration bundle from the site. The first thing we want to do is import the custom configurations for the 22. Going up to File, Import Config Bundle, we will go to our download location and simply import the .ini file. 24 presets successfully imported. So if now we go to filament settings, you'll see that all of these materials are available. Now keep in mind, these are a starting point. Depending on how quickly you're going to print, what size nozzle, some things will have to change, temperature, speed, etc. But this is an excellent starting point. The 22 IDEX also comes with a custom bed file. So instead of a basic build plate, we can have an image of the 22 itself. Now let's set the custom bed image for the different printing modes. Under printing settings, we will go to bed shape and set. It's good practice to always remove whatever image was there. Then we will go to load and choose wherever your download location was, match the file name to the type. Standard V2 for standard V2. And open. And let's be sure to save our settings. Now, we're in standard mode. Let's go to 3D view and we have the actual build plate. Let's repeat this for the other build modes. I'm going to change to mirror mode, set, remove, load, mirror, open, Okay. And save our settings. And finally, last but not least, duplicate, set, remove, load, duplicate, open, okay, and save. So here is what duplicate and mirror mode actually look like. You can utilize half of the build plate. And if we go to standard mode, you'll have full use of the build plate. I'm about to load some carbon fiber nylon PA6. First thing I want to do is heat up the nozzle I'm going to use. I'm using the left nozzle. So I'm actually going to mount it on the right spool holder because the tubes cross over. I got my left nozzle up to the temperature of PA6. So I'm going to just feed that through. On these LGXs, you pull the red tab all the way to the left, feed it through. I'll push it to the right to grab it. I will then go over to Duet. What I usually like to do, I will extrude 20 millimeters at 1 millimeter a second. Extrude, wait until material comes out of our nozzle. There we go. It also clears out the nozzle if you do a bit excess. Let that finish. Now let's just apply some nanopolymer adhesive sparingly, only to the area where we're going to be printing, right in the center. There's a few drops, and brush it in. Now I'm going to start heating up the bed. Also, heat up the chamber, which means closing the front door, as well as the top. I'm going to import an XYZ calibration cube, which is a go-to for me. And let's slice this for carbon fiber nylon. We'll just go to CF Nylon Gen 3. Under this, you'll see that this says PE. That's for the second nozzle, which we won't be using. Here's where you would actually dictate which nozzle you're using. The yellow would be the right. We're sticking to the left. I'm going to just leave this as PEI 9085 because we're not even using this nozzle. Let's check our print settings. 3 perimeters, that's fine. 5 top layers, 4 bottom. All of this looks acceptable. I think this will be one of those files where the default profile options are going to be completely acceptable. Those settings are all correct for printing this small calibration cube out of carbon fiber nylon PA6 Gen 3. Let's get a preview of that slice, see how it looks throughout. Okay, that works for me. Export G-code. Here we are at the dashboard. We need to upload the G-code for that calibration cube. We go down to Jobs. Actually, you can really do it from any window. Up here next to Emergency Stop is Upload and Start. And it's going to be looking for G-codes. When I click open, it'll begin preheating the machine and getting ready to print. There we go. Take a look at that print. That's a good looking print. So there you have it, beginning to end, step by step. If you have any other questions that we didn't address, go to docs.visionminer.com. Anything else, please reach out to us directly. Thank you for coming on this journey.